AI bias is one of the most important issues in modern technology. It affects how machines make decisions about real people. Most users do not realize bias exists inside AI systems. They assume AI is always neutral and completely fair. In reality, AI learns from human created data sources, and human data often contains hidden patterns of bias. These patterns are absorbed by AI during training. As a result, AI can repeat human mistakes at scale. Bias in AI is not intentional but data driven. It emerges from the information used to train models. If data is biased, AI outputs become biased too. This makes data quality extremely important in AI development. AI systems learn relationships between words, images, and actions. They do not understand fairness like humans do. Instead, they recognize statistical patterns in datasets. These patterns can reflect social inequalities unintentionally. For example, biased hiring data can affect job recommendations, or biased policing data can affect risk predictions. These issues raise serious ethical concerns worldwide. Developers try to reduce bias through careful data selection, but eliminating bias completely is extremely difficult. Because society itself contains many hidden biases, AI simply mirrors the world it learns from. Another source of bias comes from data imbalance. Some groups are overrepresented in training data sets, while others are underrepresented or missing completely. This imbalance affects prediction accuracy across groups. AI performs better for groups it sees more often, and worse for groups with limited training data. This creates fairness problems in real-world applications. Facial recognition systems have shown such issues clearly. Some systems perform differently across skin tones. This has led to public criticism and policy debates. Bias is not limited to images alone. It also appears in language models and text systems. AI can reflect stereotypes found in online content. Even subtle language patterns can introduce unfairness. Developers use filtering techniques to reduce harmful outputs. But filtering alone does not solve root problems because bias is often deeply embedded in data structure. Another issue is historical bias in old data sets. Past data reflects outdated social norms and practices. Training AI on such data preserves those patterns. This can unintentionally reinforce outdated thinking. AI models are only as fair as their training sources. That is why dataset auditing is very important. Researchers analyze datasets for fairness and representation. They try to identify problematic patterns early. However, detecting bias is not always straightforward. Some biases are subtle and hard to measure. Others appear only in specific contexts or tasks. This makes bias detection a complex technical challenge. Human feedback is often used to improve fairness. Reviewers evaluate outputs for harmful or biased behavior. This feedback helps adjust model responses over time. Still, human reviewers may also carry bias themselves. This creates another layer of complexity in training. AI systems are constantly evolving through new techniques. Fairness-aware algorithms are being developed actively today. These aim to reduce unequal treatment in predictions, but trade-offs often exist between fairness and accuracy. Improving fairness can sometimes reduce overall performance. Balancing these factors is a major research challenge. Transparency is another key part of solving bias. Understanding how AI makes decisions is very important. Explainable AI helps users see decision pathways clearly. This increases trust and accountability in systems. Governments are also introducing AI fairness regulations. These rules aim to prevent discrimination in automated systems. However, enforcement varies across different regions globally. Bias in AI is not a simple technical problem. It is also a social and ethical issue deeply. Solving it requires collaboration between many disciplines. Next, we explore real-world examples of AI bias and how it affects everyday life decisions. Reply: 2 inches for Part 2. AI bias becomes most visible in real-world applications. These systems influence decisions affecting millions of people daily. One major area impacted is hiring and recruitment systems. AI tools are used to screen job applicants automatically. If training data contains bias, results can be unfair. This may disadvantage certain groups of applicants unintentionally. For example, past hiring trends may favor specific profiles. AI learns these patterns and repeats them in screening. This creates inequality in opportunity distribution. Another impacted area is criminal justice systems. Predictive policing tools analyze historical crime data. If past data is biased, predictions become biased too. This can lead to unfair targeting of communities. Such systems raise serious ethical and legal concerns. Healthcare is another important field affected by AI bias. AI models assist in diagnosing diseases and recommending treatments. If training data lacks diversity, accuracy may vary. Certain populations may receive less accurate predictions. This can impact medical outcomes significantly over time. Financial systems also use AI for credit scoring. Biased data can affect loan approval decisions unfairly. Some individuals may be denied access to credit unjustly. This highlights the importance of fair financial algorithms. Social media platforms also reflect AI bias in recommendations. Certain content types may be promoted more than others. This can influence public opinion and visibility online. Bias in recommendation systems affects cultural exposure globally. Language translation systems also show bias occasionally. Some languages or dialects are better supported than others. This creates unequal communication experiences for users. AI chat systems may also reflect cultural biases. Responses can vary depending on training data sources. Developers try to reduce these inconsistencies carefully, but complete neutrality remains extremely difficult to achieve. Another example is facial recognition technology. Some systems perform better on certain demographic groups. This has led to concerns about surveillance fairness. Governments are now reviewing such technologies more closely. Bias can also appear in content moderation systems. AI may incorrectly flag harmless content as harmful, or fail to detect harmful content in some cases. These inconsistencies create trust issues for platforms. Autonomous systems like self-driving cars may also be affected. Bias in training data can influence object recognition. This can impact safety in real-world driving situations. Developers test these systems extensively to reduce risk. Still, no system is completely free from bias. Bias often appears subtly rather than obviously. It can be hidden in correlations within datasets. That makes detection and correction more challenging. Researchers use fairness metrics to evaluate systems. These metrics compare performance across different groups. Differences in accuracy may indicate potential bias issues. Data preprocessing helps reduce imbalance in datasets. Techniques like resampling improve representation fairness. However, preprocessing cannot solve all bias problems. Algorithm design also plays a major role in fairness. Some models are inherently more sensitive to bias. Choosing the right model architecture is important. Continuous monitoring is required after deployment. AI systems must be regularly audited for fairness. Feedback from users helps identify bias issues early. Real-world usage often reveals problems not seen in testing. Transparency helps users understand system limitations better. Open reporting of bias improves accountability significantly. Companies are increasingly publishing AI ethics reports. Public awareness of AI bias is also growing. Users are beginning to question algorithmic decisions more. Education plays a key role in reducing misunderstanding. Understanding bias helps people use AI more responsibly. It also helps developers build better systems. Bias in AI will not disappear quickly. It requires ongoing effort from many stakeholders. Next, we explore solutions to reduce AI bias and how future systems aim to become fairer. Reply 3 inches for Part 3. Reducing bias in AI requires multiple strategies working together. No single solution can fully eliminate bias alone. One important step is improving dataset diversity significantly. Diverse data helps AI learn fairer representations of reality. It reduces overrepresentation of dominant groups in training data. Balanced datasets improve fairness across different populations. Another strategy is careful data labeling and annotation. Human annotators must follow strict fairness guidelines. Inconsistent labeling can introduce hidden bias into models. Training teams need awareness of ethical data practices. Another solution is algorithmic fairness constraints during training. These constraints limit biased decision patterns and outputs. Models are adjusted to treat groups more equally. However, balancing fairness and accuracy remains challenging. Improving one sometimes affects the other negatively. Researchers continuously try to find optimal trade-offs. Another method is bias detection before deployment. Testing models on fairness benchmarks is very important. These benchmarks evaluate performance across different demographic groups. Differences in outcomes help identify bias sources clearly. Post-training adjustments can also reduce bias significantly. Fine-tuning models improves fairness in specific applications. Human feedback loops are widely used for corrections. Reviewers flag biased outputs for model improvement. This iterative process helps refine AI behavior over time. Transparency in datasets is another key solution. Open datasets allow public inspection and accountability. External researchers can identify hidden bias patterns. This encourages responsible data collection practices. Explainable AI helps users understand decision-making processes. When users understand reasoning, trust improves significantly. Explainability also helps detect unfair logic patterns. Regular auditing is essential for maintaining fairness standards. AI systems should be evaluated continuously after deployment. A bias can emerge even after initial testing phases. Real-world usage often reveals new unexpected issues. Ethical guidelines are being developed globally for AI. These guidelines define fairness expectations for developers. Governments are introducing regulations to enforce compliance. Companies must follow rules to avoid discrimination risks. Collaboration between experts improves fairness solutions overall. Ethicists, engineers, and policymakers must work together. Education about AI bias is also essential. Developers need training in responsible AI design principles. Users also benefit from understanding how bias works. Awareness reduces blind trust in automated systems. Bias mitigation tools are being integrated into platforms. These tools automatically detect problematic output patterns. They help reduce harmful or unfair responses quickly. However, they are not perfect and need improvement. Continuous research drives innovation in fairness technologies. Machine learning fairness is now a major research field. New algorithms are designed specifically for equitable outcomes. These models aim to reduce discrimination in predictions. Synthetic data generation helps improve representation balance. Artificially created data fills gaps in real data sets. This improves fairness for underrepresented groups significantly. But synthetic data must be carefully validated for accuracy. Another solution is adversarial debiasing techniques. These methods train models to ignore biased features. They improve fairness while maintaining performance levels. However, implementation complexity remains a challenge. Global cooperation is needed for standardizing AI fairness. Different countries may have different ethical expectations. Unified frameworks can help align fairness goals internationally. Public participation also strengthens accountability in AI systems. Users can report biased behavior in real time. This feedback helps companies improve systems quickly. Bias reduction is an ongoing long-term process. It requires constant monitoring and refinement efforts. Technology alone cannot solve fairness issues completely. Human values must guide AI development carefully. Responsible innovation ensures safer AI deployment worldwide. Next, we conclude with final insights on AI bias and what it means for the future of technology. AI bias will remain a major challenge in the future. Even advanced systems will not be completely free from bias. This is because AI reflects the world it learns from, and the world itself contains complex human inequalities. Future AI systems will become more aware of fairness, but awareness alone will not eliminate bias entirely. Continuous improvement will still be necessary every year. New techniques will aim to reduce bias more effectively. Fairness will become a core design principle in AI. Developers will prioritize ethical outcomes more strongly. AI systems will undergo stricter evaluations before release. Regulatory bodies will enforce fairness standards globally. These rules will shape how models are trained. Companies will need to document dataset sources carefully. Transparency will become a requirement, not an option. Users will demand clearer explanations for AI decisions. Explainability will be central to future AI design. People will want to know why decisions are made. This will improve trust between users and technology. However, full transparency may remain technically limited. Some models are too complex to explain fully. Researchers will continue working on interpretability methods. AI fairness will also depend on data evolution. As society changes, datasets must be updated continuously. Outdated data can reintroduce old biases again. Therefore, constant dataset maintenance will be required. Human oversight will remain essential in all systems. AI cannot independently judge fairness without guidance. Ethical decisions still require human values and reasoning. Future AI may include built-in fairness constraints. These constraints will limit biased decision patterns automatically, but trade-offs with performance will still exist. Perfect fairness may conflict with predictive accuracy. Designers will need to balance these priorities carefully. Bias detection tools will become more advanced over time. They will identify subtle, unfair patterns faster. Real-time monitoring systems will track AI behavior continuously. This will help reduce long-term bias accumulation. Public awareness of AI bias will increase globally. More users will question algorithmic decisions regularly. This pressure will push companies toward better practices. Ethical AI branding will become important in competition. Companies with fair systems will gain user trust. Trust will become a key advantage in digital markets. Education systems will include AI ethics training. Students will learn about fairness and bias early. This will create more responsible future developers. Research collaboration will expand across countries and institutions. Shared knowledge will improve fairness technologies globally. Open source tools will help detect and reduce bias. Community-driven development will play a bigger role. Bias issues will still appear in unexpected ways. Complex systems always produce unforeseen consequences. That is why constant vigilance will be required. AI systems will evolve faster than governance structures. This gap will remain a challenge for years. Still, progress toward fairness will continue steadily. Each generation of AI will improve slightly over time. Incremental improvements will reduce major bias risks. But small biases may still persist quietly. Humans will always play a role in oversight. AI will remain a tool, not a judge of fairness. Its behavior depends on how it is designed and how responsibly it is deployed in society. Bias awareness will become part of digital literacy. People will learn to question algorithmic outputs critically. This awareness will reduce blind trust in systems. Critical thinking will protect users from unfair outcomes. AI bias will shape future ethical discussions deeply. It will influence policy, technology, and society together. The goal is not perfection, but continuous improvement. Fairness will always be a moving target in AI. Technology will evolve, but human responsibility remains constant. Next, we conclude with final reflections on AI bias and its impact on the future of human decision-making. AI bias is not just a technical issue alone. It is deeply connected to human society and behavior. Every dataset reflects real-world human decisions and history. That means AI inherits both progress and prejudice. Understanding this helps us see AI more realistically. AI is powerful, but not inherently neutral or perfect. It learns patterns, not morals or ethics. That is why human guidance remains essential always. Without oversight, bias can silently scale across systems. With oversight, harmful effects can be reduced significantly. The responsibility is shared between developers and users. Developers must design fair and transparent systems carefully. Users must stay aware of how systems influence outcomes. Blind trust in AI creates unnecessary risk in decisions. Critical thinking is still the strongest protection available. The future of AI depends on ethical choices today. Every improvement in fairness starts with awareness first. Companies are increasingly pressured to address bias publicly. This transparency is shaping a more responsible AI industry. However, challenges will continue to evolve over time. New data brings new forms of hidden bias. Changing societies create changing fairness expectations constantly. There will never be a final fixed solution. Instead, fairness will be an ongoing global effort. Collaboration between nations will become more important. Because AI systems operate across borders globally, shared standards can help reduce unfair outcomes worldwide. Education will play a major role in prevention. People must understand how algorithms influence decisions daily. This knowledge empowers users to question outputs wisely. Awareness reduces manipulation and unintended discrimination risks. AI literacy will become as important as digital literacy. Future generations will grow up alongside intelligent systems. They will need strong ethical foundations early in life. Bias awareness will shape how they use technology. Responsible innovation will define the next era of AI. technology must evolve with human values at its core. Otherwise, systems may reinforce unfair patterns unintentionally. That is why continuous monitoring remains critical always. Fairness cannot be achieved once and forgotten. It requires constant updates and improvements over time. AI will continue learning from evolving human data. That evolution makes bias prevention an ongoing challenge, but also an opportunity for better systems. More inclusive datasets will improve global fairness gradually. Better tools will help detect bias faster. Stronger regulations will enforce accountability in AI. Together, these efforts will reduce harmful impacts. Yet, perfection in fairness may never be reached, because human society itself is constantly imperfect. The goal is improvement, not absolute perfection. Even small fairness gains can have large impact. AI will remain a reflection of human choices. It mirrors both strengths and weaknesses of society. That reflection makes it powerful, but also fragile. Responsible use determines whether outcomes are positive or harmful. Every user interaction contributes to system learning. This collective input shapes future AI behavior. Therefore, users also play a role in fairness. Awareness and feedback help improve systems over time. The future of AI bias depends on collaboration. No single group can solve it alone. Engineers, policymakers, and users must work together. Ethical responsibility is shared across all levels. AI will continue to grow more advanced, but fairness must grow alongside that advancement. Otherwise, progress may come with unintended consequences. The balance between innovation and responsibility is crucial. That balance will define future AI development. Society must decide how AI should influence decisions, not just what AI can do technically. Bias awareness ensures technology serves humanity better. It creates safer and more reliable systems. Ultimately, fairness is a continuous human commitment, and that commitment shapes the future of intelligence.